Hi folks, this is the next video for the year 2 differentiation, and we're looking to go for 9G. Now, we haven't yet covered parametric equations, so whilst this is your first introduction to them, it's really not that difficult a concept to get your head around. Parametric equations are where instead of x and y being connected and given in a single equation, they're given x and y given separately in terms of a third parameter. And usually we use t, sometimes we use theta, but usually we use t. So we're going to use the chain rule to work out dy dx, and we've seen this before. In some instances, this being 1, we can treat these derivatives as fractions. So we could see, if you like, the dt's would cancel out here. So I'm using the chain rule, and when I'm given x and y in terms of t, I differentiate each with respect to t. Now, I've got dx dt, but I need dt dx, so that's fine. Reciprocal. So that dy dx is dy dt multiplied by dt dx. The other way we can think of it is dy dx equals dy dt divided by dx dt, because again, if I multiply numerator and denominator by dt, I end up with dy dx. So of course this is the same thing. Multiplying by the reciprocal is the same as dividing by a fraction. Example 19 gives us a value of t, so dy dx when t equals 2 is 4/13. Now, we have an option actually. This is not our only option. What I could do, and I advise against doing this unless you're explicitly told to do so. What I could do is make t the subject, sub it into here, and get an expression in y and x. I could do that, but usually it's a lot more work to do that than to do this. And actually, it'd be very difficult to make t the subject in this expression. So unless I'm told, this is the easiest way to differentiate functions given parametrically. Unless I'm told this is the easiest way. If I'm told to find the Cartesian equation, Cartesian just means an equation with x and y. I'd make t the subject and sub into one of the others. Example 20. X is 3 sine theta, so dx d theta is 3 cos theta. Y is 5 cos theta. Dy d theta is minus 5 sine theta. So dy over dx is minus 5 sine theta over 3 cos theta. Minus 5 sine theta over 3 cos theta, which is minus 5 over 3 tan theta. Don't necessarily need that because the question's giving me a value to sub in, and of course I can sub it into either of those. If theta equals pi over 6, we are in radians here. Dy dx is minus 5 times a half over 3 times root 3 over 2. Multiply numerator and denominator by 2 minus 5 over 3 root 3. Now clearly, in my head, what I did was subbed into either of those, both of those, but of course you could equally sub into the tan expression and you're going to get the same thing. So that's the gradient. I want the normal, so my gradient is the negative reciprocal, 3 root 3 over 5. X is, now I need to know what x is. X is 3 lots of sine pi by 6, that's 30 degrees, so 3 over 2. Y is 5 lots of cos pi by 6, 5 times root 3 over 2. So let's fit it on here. Y equals mx plus c gives me 5 root 3 over 2 equals mx 9 root 3 over 10. Plus c. And c equals, what does c equal? I think c equals 8 root 3 over 5. What format does it want it in? Doesn't say. Y equals 3 root 3 over 5x plus 8 root 3 over 5. I guess sometimes they might want us to express it where this is these are not fractions, so I could multiply 3 by 5. In fact, yeah, there you go. That's what they do in the book. They multiply 3 by 5, but it doesn't say to do that. So this is a fully correct answer, and I'd submit that in an exam personally. Okay, so although we haven't done parametric equations yet, there's not a lot to do here. Differentiate them separately, divide one by the other. You may need the chain rule to differentiate, you may need the product rule, you may need the quotient rule. Okay, have a go at 9G. Let me know if you need anything.